Welcome back to Pi Academy. This is 6th video on real analysis based on sequence of real number. Others videos link provided in description box. In this video I will discuss from question 26 to 30. Now question number 26. The sequence sin n divided by n converges to 1 or 0 or minus 1 or 2. PSC 2019. Now solution. We know that minus 1 lesser or equal to sin n lesser or equal to 1 for all n. Thus minus 1 by n lesser or equal to sin n divided by n lesser or equal to 1 by n for all n. And limit of minus 1 by n is 0. Similarly, limit of 1 by n is also 0. Now by Sandwich theorem we can say that limit of n tends to infinity sin n divided by n is also 0. Therefore our option B is true. Now question number 27. Let xn equal to 2 to the power 2n 1 minus cos 1 divided by 2 to the power n for all small n belongs to natural number. Then the sequence xn does not converge or converges to 0, converges to half or converges to 1 by 4. JAM MA 2014. Solution. Given that xn equal to 2 to the power 2n 1 minus cos 1 by 2 to the power n, we know that 1 minus cos theta equal to 2 sin square theta by 2. Therefore 1 by 2 to the power n by 2 equal to 1 by 2 to the power n plus 1. Therefore 2 to the power 2n into 2, that is 2 to the power 2n plus 1, and sin square 1 by 2 to the power n plus. Therefore we adjust half into 2 to the power 2n plus 2, sin square 1 by 2 to the power n plus 1. Then we can write this as sin square 1 divided by 2 to the power n plus 1 divided by 1 by 2 into 2 to the power 2 into n plus 1. Now sin 1 divided by 2 to the power n plus 1 by 1 divided by 2 to the power n plus 1 or whole square. Therefore limit n tends to infinity xn equal to half, plus sin 1 by 2 to the power infinity 2 to the power infinity 1 by infinity 0. We know that limit x tends to 0 sin x by x is 1. Therefore this is 1 and the limit of xn is equal to half. Therefore the sequence converges to half. Hence the option C, this converges to half, is true. Now question number 28. Let xn be the sequence root over plus 1 minus root 1 plus root 2 minus root 2 plus root 3 minus root 3 and so on. If yn equal to x1 plus x2 plus dot dot plus xn divided by n for all n belongs to natural number, then the sequence yn is monotone, not bounded, bounded but not convergent, and convergent. JAM MA 2012. Now solution. Here the sequence root plus 1 minus root 1 plus root 2 minus root 2 and so on has infinite oscillation. Clearly this is infinite oscillation. And here yn equal to x1 plus x2 divided by plus xn divided by n, and clearly sequence xn is not bounded, since x1 x2 xn, that is the sequence xn has infinite oscillation. Therefore the yn, where yn equal to this, is not bounded. Hence our option B is true, not bounded. Now question number 29. Let xn be a sequence of real numbers such that limit n tends to infinity xn plus 1 minus xn equal to c, where c is a positive real number. Then the sequence xn by n is not bounded, is bounded but not convergent, converges to c or converges to 0. JAM MA 2014. Now solution. Let yn equal to xn minus xn minus 1 for all small n belongs to n, and since it is given that the limit of this, that is yn equal to c, therefore by Cauchy's first theorem on limit we can write the limit n tends to infinity y1 plus y2 plus dot 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 yn divided by n is also c, and this is equal to xn. Therefore, limit n tends to infinity xn by n equal to c. Hence, our option C is true. Now, question number 30. Let Sn equal to 0 to 1 n into x to the power n minus 1 divided by 1 plus x into dx for n greater equal to 1. Then, as n tends to infinity, the sequence Sn tends to 0 or half or 1 or plus infinity. JAM MA 2008. Solution. Here mod Sn equal to mod of 0 to 1 n into x to the power n minus 1 1 plus x into dx. It is given that the value of Sn is this, and we know that mod of integration fx dx lesser equal to integration mod fx into dx. That we know that integration a to b fx into dx mod of this lesser equal to integration a to b mod fx into dx. This rule, therefore we can write this as here x greater than, here x belongs to 0 to 1, therefore this greater than 1, and this lesser equal to 0 to 1 n into mod x whole to the power n minus 1 and dx. Therefore integrating we get mod x whole to the power n. Thus mod Sn lesser equal to mod x whole to the power n. Since limit n tends to infinity, mod x whole to the power n is 0. Since x belongs to 0 to 1, therefore we know that the mod x whole to the power n equal to 0. Thus limit n tends to infinity, Sn equal to 0. Hence the option A is true. Then now there is a question for viewers. The sequence cos n pi by 2 divided by n is converges to 0, diverges, converges to 1, or none of this. Answer this question on comment box. And that's all. Thank you for watching. Please like, share and subscribe, and hit the bell icon to get all the notification of my new videos.